Welcome to The Explainer. Today, we're doing something really cool. We're connecting the dots between Tesla's seemingly scattered engineering breakthroughs to reveal one deeply intertwined transportation ecosystem. We're going to look at how innovations at the absolute microscopic level are literally paving the way for a massive shift in global mobility. Let's get right into it. Here's the roadmap for today. We'll start with the next generation ecosystem, then we'll look at cracking the battery code, unboxing the factory, the autonomous cybercab, and finally, Model 2 for the masses. All right, part 1, the next generation ecosystem. So if you want to understand how Tesla actually managed to hit a $25,000 price tag for the Model 2 and simultaneously build a fully autonomous robotaxi, we really have to look at the hidden engineering DNA powering both of them. You can't just take a Model 3, shrink it down, and expect to magically slash the price in half while keeping your profit margins intact. No way. It requires a total top-to-bottom reinvention of the rules. Which brings us to part 2, cracking the battery code. Okay, so by late 2025 at Giga Texas, Tesla finally achieved what is basically the holy grail of battery manufacturing. They actually managed to mass-produce fully dry electrodes for both the cathode and the anode. And guys, this is incredibly difficult to pull off. It requires mixing dry active powders with a PTFE binder, think of it like a highly specialized glue, and then using a massive roller press to crush it into a film. Absolutely no liquids, no slurries, just pure dry processing. Now, to put that into perspective, for decades, the entire industry relied on the wet process. And that method committed what battery engineers call the 4 sins of manufacturing. It uses toxic NMP solvents, relies on massive drying ovens that literally consume up to 50% of a factory's energy, it fractures advanced materials through high heat drying, and it sacrifices energy density. The dry process completely eliminates those sins. It's totally solvent-free, it gets rid of those massive ovens entirely, and it actually allows for a thicker coating. And a thicker coating means significantly more energy density. So by completely severing the shackles of that old wet manufacturing, Tesla unlocked the complete form of their 4680 battery cell. This large, cylindrical cell is a beast. It delivers 5 times the energy capacity, a 16% range boost, and 6 times the power output of older generations. But here's the kicker. The dry process is so incredibly gentle on the chemical integrity of the materials that these batteries retain nearly 90% of their capacity even after 2,000 cycles. For the average driver, that means the battery is probably going to outlast the physical car itself. It's just a massive leap forward. All right, part 3, unboxing the factory. Now, for over 100 years, cars have been built on a linear assembly line, right? You take this hollow metal shell and you have workers awkwardly reaching inside to install seats and wiring. Well, Tesla just threw that entire playbook out the window. Now they build cars by outfitting sub-assemblies, the front, the rear, the sides, the floor, and the roof, completely separately. The seats, they get bolted right onto the floor battery pack while it's wide open and easy to reach. Then, much like snapping together giant Lego blocks, they just snap the whole shebang together in parallel at the very end. And building the car in parallel like this creates a massive efficiency gain. We're talking about reducing the overall factory footprint by an incredible 40%. When you're dealing with wildly expensive industrial real estate, saving almost half of your factory floor space is literally the difference between a profitable mass market vehicle and a money-losing disaster. Furthermore, Tesla is utilizing vision-based AI, which is actually derived directly from their full self-driving software for what they're calling software-defined manufacturing. Think about it. If a robotic arm is even half a millimeter out of alignment, the software instantly catches it and corrects the next robot in the sequence. This totally self-correcting assembly line saves an estimated $400 to $800 per vehicle. And every single dollar of that is absolutely crucial for hitting that $25,000 mass market price tag. Let's move on to part 4, the autonomous cybercab. Even before introducing a car without a steering wheel, Tesla was already proving its software maturity right there on the factory floor. They actually had unsupervised Model Ys driving themselves off the production line straight out to the outbound logistics lot at Giga Texas. It perfectly validated their vision-only AI approach in a real-world, highly scalable way. So building on that vision-only autonomy, the 2026 Cybercab arrives and it is radically simplified. It's a 2-passenger coupe featuring these striking butterfly doors, and exactly as promised, it strips away all traditional human controls. no steering wheel, no pedals, but it actually goes even further than that. There's literally no physical charge port because it relies entirely on highly efficient inductive wireless charging. It doesn't even have paint. The roof and body use unpainted polyurethane panels with embedded pigmentation. That completely eliminates the incredibly costly paint shop process. Grounding this highly futuristic concept in some hard data, the official EPA documents reveal an incredibly efficient machine. The Cybercab uses a relatively small 48 kilowatt-hour battery, but because the vehicle is so aerodynamic and light, weighing just over 3,100 pounds, it still delivers 219 horsepower and nearly 300 miles of range. It is built strictly for efficiency and extremely high utilization. Finally, Part 5, Model 2 for the masses. Now, the most burning question for consumers has obviously always been whether this ghost story of a $25,000 Tesla would ever actually materialize. It's been promised and delayed for years now. Well, the answer is a resounding yes. Internally known as Project Redwood, the Model 2 achieves its ambitious price target by combining that unboxed manufacturing process we talked about with a 53 kilowatt-hour LFP battery. It also heavily features a 48-volt low-voltage architecture. And that is kind of a silent hero here, because it saves about 15 kilograms of heavy copper wiring per car. Add in an eco-weave recycled interior instead of that expensive vegan leather, and you get a 250-mile range vehicle that is just fundamentally much cheaper to build. And this aggressive entry-level pricing creates an immediate massive ripple effect across the entire automotive landscape. Industry experts are warning that the introduction of a brand new $25,000 Tesla could put severe downward pressure on the whole used EV market. Specifically, used Model Ys could potentially see their resale values drop by up to $7,000 as buyers understandably flock to the brand new, highly affordable Model 2. So when you step back and really look at how these microscopic battery breakthroughs scale all the way up to make a $25,000 car and a wheelless robotaxi possible, it truly forces us to ask a profound question. With these long-standing cost barriers finally shattered, has the era of the EV as an exclusive luxury item officially ended?